I think good afternoon, all of you, and let us start this lecture. So as you can see from the title, I will talk about minor bodies, and you can see one stone, one like broom-like structures with different colors, and one scary-looking dinosaur and an object which is landing on the surface, and this creature do not know what is going to happen if this space rock lands on the surface. So before going to talk about these asteroids, comets, and meteors, so let me give you a context so that you can understand how remarkable these objects are. So let us start from our night sky, and since you know since the dawn of civilization, the human mind is integrated with the night sky, and there are stars, and there are regions between the stars which are called interstellar medium, and denser parts which are we called nebula. There is dust and gas, and from where all the stars and all the planets are formed. So these small dusts, so as it is in this interstellar medium, at some point of time, it will also be incorporated in the planets. So now, if you look at a little bit more detail, if you have a little bit, you have a small telescope and look at it, you can see this beautiful Orion. And just let me take a cursor. Yeah. So if you look at this region, there is a very famous nebula called Orion Nebula, and you can see the stars and planets are being born in this. This is a beautiful Hubble image of this Orion Nebula. So at this stage, we have matter. So our sun or our solar system also formed from such one of such nebula. We call them solar nebula. And if you have more telescope time and if you look at it, you can actually see the disk in this and the planets being formed. And of course, when planets are formed, then of course you get all the planets and other stuff. So now, if you see what happens to this material actually gets gravitationally collapsed. So due to their self-gravity, and this matter also has some rotation of the angular momentum. So what will happen when this matter will collapse? It will form a disk, and in the central part of this disk, where there is the maximum matter, we will form our star, or in our case, the sun, and then in the disk we will form all the planets like our solar system planets can be formed. So this is a small schematic video of this process. It looks very nice, but the process are immensely complex, and there are a lot of insight, and it is still not, we are not still able to decipher how this has happened in our solar system itself. So now think about that, we have exoplanets, and so how complex these things are. So in this scheme of things, so first planet we think is to be formed as a Jupiter. So now, once Jupiter is formed and the gas giants are formed, and these are actually the planetesimals which also evolves with time from this very small micron size to planetesimals and dusts. So during this phase, if you look at this, how this, okay, this is this video. Okay, so you can see this. Just let me. Yeah, so you can see this when these asteroids starts scatter, it will get scattered by Jupiter and bigger planets, and these terrestrial planets will form here. And you can see one remarkable event happened, that Jupiter actually moved inward and then come backward. That is, it moves towards the sun and then it came back. So this happens due to the imbalance of these things, of this disk material. So what in this sense you see that all these small rocks, in this case the planetesimals, they are actually getting mixed, and you can find all over the solar system. So now you can see here these rocks actually forming terrestrial planets. They are very small in this case here, and these terrestrial planets are being formed from these rocks. But not all these rocks are incorporated in planets, and the rocks that remained as a leftover from the solar system formation are the comets and asteroids. So you can understand how remarkable these objects are. They are actually time capsules. They preserve the various physical and chemical events that happened in our solar system, and this planet formation and these the videos that I have shown is to make this thing. We need the knowledge and the understanding from this comment. So we need to, so they are very important. And so you can see that these are also the least altered objects that is surviving the protoplanetary disks. So all these planet formations and many other aspects that we see in the solar system, we have to gather knowledge from these asteroids and comets, and these are actually very critical part. So as I have already shown in this video, so this rocky, one second, I have to get this pointer. Is that? Okay, you can. So this is these asteroids are the building blocks of rocky planets that we have already seen in this video, and so you can understand that if you want to study this formation process and their diversity, it can give us very crucial information. Not only that, it is believed that these asteroids and comets, there are a lot of organics is there. So when you study them, we find a lot of organics. So it is believed that they have actually in various phases, they bombarded the planets like Earth with asteroids and comets, and in the process they can brought the organics, which are the seed for life, so that it has immense astrobiological implications. So one very important aspect, you know, that it is believed that the water on the Earth is actually brought by asteroids mostly. So not only that, there are you need to also study them a little bit from the hazard point of view also, that I will show in some of the view graphs. So you can see that some of them can be hazard to the Earth, and the extinction of dinosaurs is believed to be the catastrophic consequence of the asteroid impact. Not only that, so considering the various space explorations from various agencies, we can see these asteroids can actually serve as intermediate stop for future space mission and can also provide resources. These are only few very small ones I listed, but there are enormous benefit if we study these objects. So now let me give you a definition of these things, these objects. So solar system, small bodies we define which is not a planet or not a dwarf planet or not a natural satellite. So it is a definition given by IAU 2006 meeting, which is also actually voted out Pluto as a planet. So with that, they create a separate class of dwarf planet, and some of the asteroids like Ceres, which was so big that they have classified as the dwarf planets. And now the asteroids are mostly the rocky airless remnants, but the comets are mix of dust, rock, and ice also. So here by ice I mean that water ice and various CO2. If you can go to very low temperature, they can also form ice. So as a result, so if you heat a comet, so you will see that lot of gases like water, CO, they will evaporate out and they can create some sort of a small atmosphere for comets. But asteroids, they are primarily rocky objects. So you can see there are this is the main difference between them. So as you can see that I have not shown asteroids, the meteors here. So let me talk about a little bit the meteors. So it depends on where you observe them. So meteorite, let me talk about start from the meteorite. This is a very small object, a small part of can be an asteroid, but this is importantly in this space. So that means it is not entered our any planetary atmosphere or anywhere. So when it is in this space, we call it a meteoroid. When it enters the atmosphere, like Earth atmosphere, we call them meteor. So you can understand the shooting star, basically what you call them. But also importantly, some of them can also fall on the Earth's surface. We call them meteorite. So you can see essentially they are part of the asteroids or comet objects, basically dead comet objects. So in essence, if we study you want to study these asteroids specifically, we can also study these meteorites so that we can get information about it. So now let us see that let us know about asteroids first. So you can see that in early 19th century, so there was a huge race to discover new planets. And in the event, big asteroids got discovered. So this is the first object the asteroid discovered was Ceres. Although now we know that the IU has classified it as a dwarf planet, but till 2006 it was an asteroid. And next it was discovered. The next is like Pallas, then Juno, and then the Vesta. So you can see there are race to find comets, mostly find big asteroids. And since then, large number of asteroids are being discovered. So the asteroids are mostly found in the main asteroid belt. So you can see this here is Mars and here is Jupiter. So this main asteroid belt is here. So here most of the asteroids, the large number of asteroids we find. And typically, if you look at their size, so if you talk about asteroids of 1 kilometer size, so typically you can get 1 to 2 million of such asteroids. But if you talk about meter size objects, so it could be hundreds of millions. So basically, smaller is the size of the asteroid, larger is the population. So you can understand this large number of asteroids, very small to very big one exist here. But besides main asteroid belt, it can also be found in some very sweet spot in the planets, so which are called Lagrangian points. So this is a point where the gravity of both the star and the planet is equal with the centripetal force of the objects here. So it is most stable. It is a very stable region where these asteroids can stay. So here you can see in this picture you can see the Jupiter asteroids. So these are called actually Trojans. And for Jupiter, there is the large number of these Trojan asteroids are found. For Earth, only in 2010, one very small object, Trojan asteroid called TK7 was discovered. You can see its very peculiar orbit. Okay. So now I talk about a little bit about these near Earth asteroids before going to talk about what we know about them. So typically there are like 1 million objects are there. They can be hazard to us, and therefore we need to study them as well. So here I can show you one picture. This is a asteroid hit a car. Actually, it also injured a schoolgirl in 1991, and basically you can now understand that this is a part of an asteroid only which land on the surface. So we are calling them a meteorite. So just in 2019 in Bihar, people are working in the field, and a big asteroid landed in the field. So you can understand if they hit a person or a building, it can make a significant damage. So typically, and in this month itself, some of you might have seen a 1 in a billion event, French woman hit by a meteorite while having coffee. So this is a news article, you can Google it and find it. And so there are a list of some of these damages people can find this. So therefore near asteroids have some special category which we have to pay attention to know they are actually the prospects. So this is one event happened in just 1994. I was a school student there then, and we used to follow. This is a famous Shoemaker-Levy 9 impact. A nearly 2-meter size comet got disrupted and hit Jupiter. So now you can understand if such a object hit Earth, it can bring a very catastrophic destruction on the Earth. So typically, if you look at this in many Earth, there are many places we can identify regions where in past asteroids made big impact craters. So these are some objects, the near Earth asteroids, so which we should take care of them. So here I think I quickly mention from the planetary defense point of view. I think you have heard about NASA's DART mission, where they have impacted spacecraft to alter the orbit of a comet. So you can, these are very important aspect for modern days to know about their particularly asteroids which can approach us. So now let us know a little bit more about these are. So now we are knowing that where we can find them, and also a little bit about some of the asteroids which could be hazard to Earth, and we should monitor them. So now let us know about their a little bit more thing like compositions, for example. So typically, the compositional difference of asteroids is mostly related how far from the sun they are formed. So based on that, there are typically three types: C type, S type, and M type. So C types is basically the chondrite type. So they are actually comprised of a large amount of carbon, although you can get nitrogen, oxygen, hydrogen, but they are small quantities. And they actually resembles their composition. So if you can see their isotopic ratios, you can find them very close to the sun. So they are actually the most primitive object, and they are primarily found in the outer regions of the asteroid belts, main asteroid belts. And also, if you look at them, they are very dark objects as well. So there is a quantity called albedo based on that how much light these objects reflect. So their albedo is like only between 0.03 to 9%. You can assume like only 3% to 9% light is coming out from this. So you can understand how difficult is to observe them therefore. And their density is also typically low, like about 1.7 gram per centimeter cube. And then we have like S type or stony type. So they are primarily made of iron, nickel, magnesium, and silicate materials. They are relatively bright. I will come more about all the some of the individual asteroids to talk about other things. But typically they are. I want to tell you a little bit. Typically their average density, their albedo, and these stony type asteroids mostly found in the inner asteroid belt. And there are M types or metallic asteroids. So they are mostly made up of nickel and iron, and typically they are also little bit more brighter than the S type, and almost have similar density, and all they are also found in the inner asteroid belt. Okay, so now let us see some of the missions that has gone to the asteroid to study them. So the first mission, space mission, which imaged an asteroid, is Galileo flyby. Galileo was a mission specifically designed for Jupiter, but it also imaged an asteroid called Gaspra. And you can see this image. So if you look at this image, first thing it strikes is that it is a very irregular size. So you can understand. So this is from one end to other end is about 18 kilometers is the greatest length. Another very important feature that you can find is you can see a lot of craters. So small craters. So you can see actually small craters you can see. So that means these objects are also bombarded with small micrometeorites or small piece of asteroids, or basically meteoroids. So this is it's also, people find that it is also rotates counterclockwise once every 7 years and 7 hours. So next, actually NASA's Near Shoemaker, which is the first spacecraft to land on an asteroid. So this is a S-type asteroid EOS. That image I have already shown, and this also first orbited this spacecraft, and then it landed. So here they found the EOS surface is smooth and flat, and also it is littered with large boulders. So, and also they found that this object didn't experience any differentiation. I think you have already learned from Professor Banerjee's lecture that the differentiation, it's a very important process that happens to the bigger solar system objects like planets. So, but these objects did not go through the extensive melting or differentiation. And it also give us a very wealth of data, particularly the image of objects as small as 1 centimeter. Next in the list is it's one of the very remarkable missions, NASA's Dawn mission. So which actually studied one of the bigger asteroid, Vesta, which is actually second largest object in the asteroid belt after Ceres. And here you can see its diameter is about 530 kilometers. and it is almost spherical. So you can understand. So this object is so big, it already tried to get the hydrostatic equilibrium, and it is also found out that it is a differentiated object. So it is not like the smaller asteroid that we have seen earlier. That here actually in VISTA you can identify the crust, mantle, and core, and it is believed that it has a iron core. You know that as a differentiation due to this as a process of differentiation, this hot-lived radioactive nuclei generates so much heat that it melts, and the heavier elements sink. So this is how you can get a iron core, it is believed. And it is also like that. It is also found heavily cratered. So you can see here a large number of craters, and some of them are very big. Actually, there is an object found, the very big impact basins found in the southern hemisphere, which is called Rhea Silvia, which is like which central peak is as high as like 22.5 kilometers. It's almost 2.5 times the Mount Everest, and it is one of the highest peak, like Olympus Mons of Mars. And then there is also very other bigger crater is found. So we can understand the very large object hit this asteroid. So when this happens, when this large object hit this asteroid, so what will happen? So it will eject a lot of material in this space. So basically we can call them vestoids. So this debris ranging from very small size to smaller asteroids ejected in space. And this material then can have their own journey in the solar system. Basically, some of them can hit Earth, and some of them can hit Mars, and things like that. So scientists believe that nearly 6% of all meteorites found on Earth are due to ancient impact in deep space. And not only that, for VISTA, by studying the isotopes, you can actually identify VISTA as the parent body of the HED meteorites, which is a class of meteorites. Not only that, here we can see in VISTA the sign of we can find some gullies region. So basically, it happens when a fluid flows on the surface, like water flows on the surface. You can see a structure. So this kind of structure is also found here. But in VISTA, it is found that it is volatile depleted. So next object it is studied is the Dawn. NASA Dawn studied the Ceres, which is once again an ocean one. So you can see there is large diversity in the asteroid class. So you can see smaller ones, and this is the bigger ones. And then I will talk about two more such missions which brought back sample to the Earth to study. One is the Hayabusa mission to Itokawa by JAXA, and this object is a S-type asteroid, and it is found that it is a rubble pile. So basically, it is a collision shattered a large object, and the rubble pile is created, and which made this asteroid. And here it is found that the captured dust is found that which can be only formed deep inside the rocky planet. So boulders as big as 50 meters is found. Not only that, about 1,500 extraterrestrial grains are recovered, and actually you can write a science proposal and request samples, and you can study them in your own lab. So, and when some of the studies already revealed that it contains like olivine, pyroxene, pageuclis, iron sulfide, etc. And then another mission I will talk about, Raibu, which is and once again is a very famous mission. And here it is found that it is a very primitive. Its material is very primitive. Once again, it is also a rubble pile and born from a collision, but it is found to be surprisingly dry. Although some grains or some objects are found which is altered by water. So you can understand. So from there, here we can conclude that probably it has flown close to the sun or formed in a region which is the outside of CO2 or H2O snow line. So we can actually infer a lot of information by studying them. And in this object, as many as 10 types of amino acids are found, including the simple amino acid glycine and alanine. Not only that, aromatic hydrocarbons, nitrogen compounds are found. So you can see that so amino acids like glycine can be formed in the asteroid. So when they hit a planet like Earth, so bring this material also on the Earth. Okay, so now so you can see here that the from these 5-6 asteroids that I have discussed, so there are small ones and there are big ones. Big ones are differentiated, and among the small ones, some could be rubble pile. They could be formed from the impact of the other object. Not only that, some of the impacts on the bigger asteroids can eject material and which can reach a planet like Earth. So now let us talk about comets. So I already talked about that the comets are icy balls, and they are also the spectacular objects in the night sky. If you are a hobby of making good photography, just anytime a comet comes in the sky, photograph them. They are wonderful, very beautiful objects. So here I have shown the pictures of some of the great comets. So one thing I want to make you notice that they look at this comet Hale-Bopp. It has a like bluish, like this is called actually tail. I will come to that. And this is whitish region. So then there is a green comet. So you can see it has there, some of the comets are very spectacular in their color also. So so here I want to make one thing clear, that these objects are just a snowball of frozen gas when they are far from this sun. So what we see in this image when they come close to the sun. But if you try to observe them far away, first of all, we cannot observe them. They're very small objects, and you cannot see them with the present telescopes. And they are only snowball, frozen snowball. Only due to the solar radiation, their atmospheres are formed. So I will just one slide. I will discuss this quickly. So this is another very interesting object which is observed in 2019. This is an interstellar comet. So it is coming from a different planetary system. So you can understand it's a beautiful. You can see this comet is once again very bluish. So this is a comet, so which is coming from a totally different planetary system. So you can study the comet's orbit, and you can say whether it is coming from a solar system or it is coming from a different system. So you can understand that how important such a comet is, that here you are studying an object. Basically, you are studying an interstellar object, and which is coming to your backyard to study them. If you want to send a spacecraft to find a comet like or any object in a different planetary system, it's a huge time scale with the present speed of the rockets. And so now let us talk about the cometary reservoirs in the solar system. In solar system, beside these asteroid belts where you can get the asteroids, there is also other regions where you can get these rocks. So one is Kuiper belt, which is like you can see a few hundred AU to close to 1000 AU. So from here, the comets which comes, they are basically called short period comets. So their orbital time usually less than 200 years. And the comet Halley, which is probably one of the very famous comet in human history, is coming from this Kuiper belt. And then other class of comets which comes from this region, which is called Oort cloud. So which is even far away, like up to 100,000 AU, or basically 1 lakh AU. So if I look at this object, so you can see in the Kuiper belt we have around like 10 to 9 to 10 to 10 number of comets, and their ambient temperature is only like 30 to 60 degrees. So what we can see, these are actually the freezer. So you are like freezing when you want to store some vegetables or something in your house, you put them in freezer. Here you want to store a solar system sample, you put them in Kuiper belt. And I will show in the next slide, you will realize that how beautiful freezer a Oort cloud is. And these comets mostly comes from the Kuiper belts due to the planetary perturbations, because they are very small objects. So any gravitational perturbation can bring them in the inner solar system. And in the Oort cloud, we have like 5 times 5 into 10 to 12 comets. So large number of comets are there. And now you can see it is only 5 to 6 Kelvin. It's a super freezer. So this is how this sample. You can understand how beautiful, how interesting these objects are. And from here, a comet can form due to the perturbation due to a passing star. So they are so outer, so far away. So now you just realize how interesting these objects are. That if you know that our the man-made the satellites, they have traveled up to only 157 AU or so. But here we are getting samples in the form of comets which are coming from a 10^5 AU. So once again, you can understand how interesting, how fascinating is to study such an object, that it is some object which is coming from a different planetary system, and here even in the solar system, coming from a place where probably it will take quite a long time and a challenge, technologically challenged, to send our spacecraft in these regions. But they are coming in our backyard and we can study them. So you can understand how remarkable these objects are to gather information. Although there are a large number of comets, only small number of comets we have actually identified, and only even smaller are now numbered and smaller are studied. But these are basically the numbers people calculated from various mathematical understanding and various models. Okay, so now let us look at their size. So comets are very small size objects, so only few kilometers. So it's not like asteroids. You can get asteroids like Vista, which is like more than 500 kilometers, but comets are mostly few kilometer objects, and they are primarily made. So I have already mentioned they are also made up of ice. So you can see they are mostly 80 to 90% is water ice, and then of course you get some CO, some CO2, and other species. And now you can look at the organics. These are major organics in terms of the amount you get. So here these are the organics where you get more amount, a large amount of. So this number tells us that in how many comets you get these organics. So you can see several comets we get very large of various types of organics. So if you want to list them, it's an enormous list. So you can, it's a large number of organics are found. I have listed that. If you want to go into detail, you can look into this article. And these organics are found in the atmosphere or the coma of the comet, and you can also find them in the cometary nucleus. So what you can see that these comets can indeed deliver large amount of organic materials like asteroids. So now let us look into a little bit more detail. So as I was telling, that far away they are actually the dirty snowball, and when they are coming close to the sun, so like about 5 AU, so some of the ice actually starts to melt. So as a result, you get this kind of fuzzy atmosphere around it, which we called a coma. So planetary atmosphere is coma. This is how it is defined. Now when come below the 1 AU or so, you can see that it forms basically two tails. One actually, this is you can see dust tail, and one is ion tails. So once they cross the solar system and then come far, so once again they became an icy ball. So these are the object. Here you can see the atmosphere are being in front of your eyes. So that it's actually laboratory to study various atmospheric processes. So now let us see that the what are these ion tails. As I have mentioned here, that is, it has two tails. One is ion tails. This is ion tail, and it's a dust tail. What these ion tails are made up of? So they are primarily made up of like CO plus, N2 plus, CO2 plus. Then there are H2 plus, H3 plus, a lot of other types of ions. And these ions, as you can understand, then since they are ions, so they will also interact with the charged particle that is coming out from the sun, right? So not only that, it will also interact with the magnetic field, and therefore these ions will actually always point away from the sun, and we get the ion tail because this just aligns with this magnetic field. So that is how we get the ion tail. And as I was telling, the colors also come from these ions. So if you look at the blue comets, so basically CO plus absorbs sunlight and it emits in the wavelength of 4,200 angstroms. Similarly, for the green light can come from a species called C2. So now let us do a little bit of a mathematics here. So what you can see that as I was telling that these dust, how dust tails are formed. So you know that the solar photons carry momentum, right? So you can calculate this momentum by energy divided by C, and then you can calculate the force, the rate of change of momentum, and finally you can calculate the pressure by dividing the area that is swiping this region. So now if you look at a particular grain of size R, so you can get the how much force this dust is experiencing. Actually, you can do this as a homework. So you can find it that if your grain size is smaller than 0.006 or the 60 micron, so your photons can take away, and the bigger grains will stay in the stay back. So that is what you can see. And so but another thing is that what I want to tell that I already talk about the ion tails. You also see some whitish color, like blue whitish color. This is basically dust reflects sunlight. So this is how, so you can now understand when you see a comet, you can understand how you get these colors. So you see, when you see the ion tail, you will get this blue, green, different kind of colors. And when you see the dust tail, you get like yellow, white is basically dust reflecting the sunlight. Okay, so now let us understand about the little bit of talk about the space exploration of comets. So comets is, before going to that in this slide, I'll just spend a few minutes on another point, that these comets can also be observed from the ground-based telescopes, which I will just mention towards the end of this talk. So large number of observations are also gathered from the ground-based observations, but these observations basically target like what kind of ions are there, what kind of neutrals are coming out, and things like that. But if you want to study what kind of a material in the cometary nucleus, then you have to make a space exploration. And the first, very notable, there are many explorations. I will not go into detail due to the lack of time. So first notable exploration is the Giotto, which studied the comet Halley. So as I have mentioned, the comet Halley is probably the one of a very favorite comet because it was the first comet for which the orbit was predicted, and it was predicted that every 76 years it will come back. So here, first time people have in situ measurement of the cometary atmosphere, and it can also find out the irregular shape of this comet. and not only that, it observed that when the spacecraft is far away, and as it goes towards the comet Halley, it sees that how atmosphere is being formed. So this was the first very important mission which studied the cometary atmosphere. Then it comes the NASA's famous Stardust mission, so which is the first spacecraft to return a sample from the comet. So here, very interesting observations are found. So first thing we found from this sample, studying this sample. So basically, you can many of these samples you can write proposals, and you can get them, and you can analyze in your own lab itself. So very interesting facts that we find from this, that this cometary dust that is collected from this comet Wild-2 is very primitive. That I have already mentioned. So it is bound to be very primitive because they are the remnant of solar system. Not only that, it is also found they are significant. They do not alter significantly. So they are very least altered. It is also found. Another very interesting thing, it is found that in this object, people found the samples which can only form at very high temperature. Now think about it, these comets are mostly resides in the outer edges of the solar system. So as a result, they are bound to be very cold. So they are bound to be, we should not find material which is required high temperature to form. So that means that some material is coming from which is from the close to the sun. It has formed close to the sun. So it clearly tells that this material formed or was altered much closer to the sun. So it also tells us this is probably the large-scale mixing happened in the early protosolar disk. So few things. So it is primitive. The material is primitive, but it also bears signature that the large-scale mixing had happened. So you can understand that you can use this information to characterize your protoplanetary disks. Not only that, we found the material is also heterogeneous. That is, very different types of materials are found. So that means they have different histories. So you have several materials which has different formation histories. So you can actually, from their formation histories, you can find out how the environment, our nebular environment, while our solar system formation, how varied they are in the various regions of solar nebula. So, but in this case, in this comet, we didn't find much of the organics. Probably it is believed that detection technique has to be blamed, but but the insoluble organic matter is found in this comet. So then I will talk briefly about this ISRO's Rosetta mission. So you can understand this is one of the very exciting. Probably you are very interested during your school times about these comet Philalanders and this mission and Philalanders and things like that. And it found also very, very interesting fact. It's also actually imaged this the comet 67P, how its atmosphere is being formed. You can see that when it is approaching perihelion, so you can see here this atmosphere is formed. But when it is far away, so you don't see much of this activity. And not only that, it is also is found its shape is very peculiar, like it's a duck-like shape. So probably in its formation history, probably two objects collided and from this object. And not only that, it is also found that the most of the activity is coming from this neck region. And besides, it is two very interesting things found. We found that it has like very young surface. So so surface, probably that means that the various impacts ejected gas and then it falls on the surface. So therefore, the surface material is very new or very young. Not only that, the different lobes has heterogeneous composition. That means these two lobes share different history. Not only that, it is also found that it has if you look, Rosetta studied its vertical stratification. So therefore, it found that the upper layer is porous refractory dust, but in the below, underneath, there's a hard ice is there. And in this comet, very large number of organics are found. So you can remember the table that I have shown earlier. That is, half of these organics are probably more than half of organics are the result of these observations. So that means that you can actually these physical you can correlate these physical properties of various volatiles and refractors in the cometary nucleus, and they are also interrelated. So let us now quickly talk about this thing that I have mentioned briefly, that the water brought by various asteroids comets. So after this Rosetta mission, so they have studied the D/H ratio of Rosetta 67 comet. So you can understand the D/H ratio like is a DNA. So by a DNA study, you can identify, pinpoint a person or any creature. So here, if you find the isotopic ratios, actually same isotopic ratios means that nearly same origin. So here you can see the chondrites that I have discussed, C-type asteroids. So they are actually believed to be the primary source of the, when you plot the DH ratio comes very close. But also one or two comets also comes closer in this list. So this study once again confirmed that probably instead of comets, asteroids brought the water on the Earth. So now we'll talk about some of the new upcoming missions, but these are only small lists. So there might be many missions in the planning stage, which we will be knowing in maybe near future. So the first in this list, which I have made, is from OSIRIS-REx, which will brought like 60 grams of samples, and it has already collected sample, and it is expected to land on Earth on September 2022, this year itself. And then NASA's Lucy's mission, which is the first mission to study a Trojan asteroid of Jupiter. So so far we have not studied any Trojan asteroids. And then there is NASA's Psyche mission, which will study the metal-rich asteroid. There is still this is the first sample from the first study of a metal-rich asteroid. And then there is a mission from JAXA, which will study a dead comet. So what will happen? So you can understand the comets are a mixture of dust, rock, and ice. So what happens when entire ice is sublimated? So it remains dust and rock. So this mission will study this. Then there is another mission by ISRO, which will also try to study a very pristine comet. But these are only very small list. But there may be many missions coming which will be knowing in future. So now let us talk about some of the unsolved problems so far. So as I have already said that we can already got the evidence that the large-scale mixing of this material that happened in the protoplanetary disk. But the number of samples we have found so far is very small. So what we need sample return missions, more sample return missions, and the in-situ measurements is required. Some of the important aspects we can study is the study of the diversity of materials. So now we have only small set of samples. There itself we are seeing that their mixing is heterogeneous. So what we need to find is that large number of these samples, so to understand how diverse these materials are. Not only that, we are also seeing the objects like the objects which is required high temperature to form in the comets. So that means they actually transported. So they are actually mixed. So as a result, we need samples from different reservoirs also. So we have seen that the asteroids are in the asteroid belt, then comets are in the Kuiper belt, and then Oort cloud. So we can see there are different reservoirs, and these reservoirs are also very huge reservoirs. So we need many samples from different reservoirs, and we also need samples for different evolutionary stages to understand these small objects. Another important aspect that we have not able to study is the frozen ices. So far there is no frozen sample from comets cannot be collected, but this is a very important piece, because without this our understanding could be incomplete. Not only that, we should have dedicated mission to study the organic matter, so which is very important, because so that can tell us what kind of organic material our Earth has received. So we have only found certain organics like amino acids from various observations, but we need to make a much more elaborate study for that. Not only that, we need to also try to find out objects which is interstellar origin. So as you can remember my early slides where I have seen that I have shown that basically this matter is the dust and the gas which is residing in an interstellar medium in a nebula, and then the gravitationally collapsed and formed them. So therefore, if we can search properly, we can actually find material which is interstellar origin, and also we can study them. So far we have studied some of the comets, but they are mostly nearby comets. So we need to study really pristine comets. So which can in that case we can expect to find the interstellar materials. But also we can study the space weathering in the asteroid study, and of course we also have to study and monitor near-Earth objects, because these are not only the potential hazardous asteroids, but in principle you can actually get resource from this. I think you have found many news articles like diamonds and variable materials from the asteroids, and actually we can get some resource from these asteroids also in principle. So therefore you can see there are some of the important scientific objectives that we can have. So now let us come to some of the contributions in this field from Indians, that is the scientists that in India people have done. So this is one of the very beautiful object, the view graph. This is actually image from 1949, as early as 1949, and this is a comet which is discovered by Vainu Bappu. You can see the name of this comet, and this V is represent. I don't know whether you can see it or not. I have circled it. This is actually the location of the comet. If you can go into the net and find, you can really find very small evidence, and these are actually the field stars based on which this is observed. So this is a this is one of the earliest, I think, observation in India I can find. And after that, there are during the Halley's comet in India, we have a Halley observation program which is coordinated by Professor Chandrasekhar, and a large amount of publications and very good amount of science results. I'm not going into the individual science results because due to lack of time, but you can look at some of the papers I have cited here. If you want to look at their contribution, you can actually find them. So basically, at initial days, people study about the photometry. So basically, and then in latter stage, like people also started already started studying the spectroscopy studies. So basically, you can, by spectroscopic studies, you can identify various molecules in the or species in the planetary atmosphere. So you can see some of this paper I have cited here. And these are some beautiful observatories that is you can find. I have only listed few. There are many more. So you can see the PRL observatory here. We can see this is our 1.2 telescope, and this is 2.5 telescope with very beautiful instrumentation. And this is a very small one, small telescopes as well. So now we have this Himalayan 2-meter Hanley telescope. We have 3.6 Devastal optical telescopes. I think many of you know. And then we also have Bappu telescope in the operated by IIRS, and there are many such telescopes. I just have shown you some of them, and particularly this 2.5 with very beautiful state-of-the-art instrumentation is going to come in PRL, which will be very good for spectroscopic studies of the comets. So not only the observations, so there we have large heritage of studying the modeling studies. So you can see this in the 90s. These studies are started by Professor Bharadwaj, Professor Haidar, and then which is carried forward. Not only that, recently we have built the first model of the interstellar comet to Borisov. So you can actually, if you are interested, you can look at these papers. Not only that, in PRL, we have all the theses are archived. So all the theses on solar system, small bodies from PRL, be it comet, be it asteroids, you can search in this link actually. So you can, and when you go to the thesis, do read the introduction chapter. That gives you a very fantastic flavor of the full subject. Then, of course, we have a very cutting edge instruments to study the meteorites. As I have already told you, this meteorites basically a piece of asteroid only. So you can see this image is a NanoSIMS, which is a very fantastic, and it's a state-of-the-art instrument which can actually study various features in the nanoscale using the elemental or isotopic distributions can be studied. Then it is a this is another instrument called inductively coupled plasma mass spectrometer. It can gives you the elemental concentration. You can remember the elemental study, that is the isotopic ratios, and other studies are very important to. These are like DNA to identify the origin and formation of these objects. Then we have other instruments like noble gas mass spectrometer, NGMS, which studies the isotopic ratios and concentration of noble gases. Then we have like XRF. With XRF, you can study the bulk composition. Then there is other instruments like EPMA, that is basically electron microanalyzer, which we can study the elemental analysis. And this is the instrument which can study the sample non-destructively. Then, of course, many of you probably know about the XRD, which is a X-ray diffraction. So you can study various different mineral phases. So you can understand. So you can actually visit PRL websites. You can get all the informations of these and of these instruments and which are having in PRL. So now, let us. I'm now towards the end of my presentation. So I will first give you the take-away messages. So first, let us start with the comets. So you can understand the comets are among the most pristine objects in our solar system, and they reside primarily in the outer solar system. And what we found that the material is heterogeneous and come from a wide variety of formation environments and have different detailed histories. So you can understand how important is their studies. Not only that, we have interstellar comets which can reveal information about other planetary systems and can also be compared with our solar system comets. So besides cometary atmospheres, forms and disappears, so it gives a it can be treated as a laboratory to study various atmospheric processes. Then, of course, there are several missions like Rosetta studied these missions, these properties very effectively and very efficiently. And not only that, comets are mostly water dominated, as I have mentioned, and the large number of organic molecules are found in the comets, including the amino acids, and which have immense astrobiological implication. So not only that, one can study the formation and destruction of these molecules in the cometary atmosphere using the modeling study. So then in the asteroid part, asteroids are rocky airless bodies. They primarily reside in the asteroid belts, but they can also be found in the Lagrangian points of planets. In fact, Earth also has a in Earth at Lagrangian point also we have a asteroid. And then in terms of composition, so which are basically compositions of these asteroids are related to the how far they form from the sun, and they can be classified as the C, S, and M types. And C types are the earliest object in the solar, basically chondritic type. They are the earliest object in the solar system, and we have seen that whatever asteroids we have studied, they're heavily cratered surface. So that means a lot of smaller asteroids or micrometeorites, meteorites, they land on these asteroids and they crater it. So they make a lot of impacts. And not only that, the bigger asteroids can be differentiated like our planets, and some asteroids are fragmented part of the bigger asteroids, and then they can be considered rubble pile. So this is another important fact, that it is the evidence of a large number of collisions in the early solar system. Then the large number of organics, including simple amino acids, are also found in asteroids. So same as like comets. So not only that, some of the asteroids can be hazard to human civilization, therefore they should be monitored. So finally, you interested to know more work on the comets and asteroids, regularly look at the websites of various ISRO centers and associated programs like START. In PRL, we have JRF program, and there is also various opportunities and job vacancy comes. And not only that, in PRL and also many other institutes, we have like 4 to 6 months and 10 to 12 months of projects, which you can work on. And in the material, I have given the extensive list of the reading, but some of the very important ones I have mentioned here, like Asteroids 3, you can get online fully. Comets 2, you can get fully online. Even this book is also, you can search it online and get it. And these materials are very good to study about the comets and asteroids in much more detail. So for any questions, you can ask now, or you can post them in my emails.